Very good evening, everyone. So let's begin with our presentation session. Those who want to give presentation, please raise your hands. We will go in sequence with the raised hands. Okay, so first we have Kushagra Chaturvedi. You can start your presentation.
Am I visible and audible?
Yes, you are audible and as well as visible. You can start.
Okay. Okay, ma'am, it's showing host has disabled participant screen sharing.
Yes, 1 minute. Now try.
Yes, ma'am. Okay. So, can you see my presentation?
Yes, it's visible. You can start.
So, good evening, everyone. My task for today's presentation is overviewing of project Synopsis, and the project for which this synopsis has been provided is stock prediction using machine learning algorithms, and it's an end-to-end project basically. So in this project, what we have to do here is we have to develop a machine learning solution so that we can build a predictive model based on the historical stock market data that is already present with us. And the objective for this project will be we have to predict the future market trends and the movements so that we can aid the investors and the future customers that will be investing in the stock market, so we can use the our predictive model to provide them with valuable insights on the stock market trading system. And to approach this project, what we have to do, we have to utilize the historical stock market data that is already available on various sources like Kaggle or various other data sources, and we can utilize those data sources to build a end-to-end platform where we use supervised learning algorithms and other algorithms that are used to like time series algorithms, so that we can have a good predictive model and uh, feature engineering techniques so that we have a better result. Now coming on to the project timeline. So for the first phase of this project, what we have to do is we have to collect the data and pre-process it. So data collection and pre-processing is one of the most important parts related to any machine learning or deep learning project. So here first we will be collecting data from various sources, and that data is the historical stock market data. And the second part will be to pre-process that data. Now, pre-processing the data set includes various steps like data cleaning, data integration, data transformation, and dimension reduction. These are four basic steps that are included in the pre-processing step. There are many other steps we can also use, but these are the four basic steps. So we will be cleaning the historical data that we will be getting, and we will also integrate various variables, or we can uh, make the data so that we have a better model, like if we have categorical variables, splitting them into either label encoding or one hot encoding. So based on the type of categorical variables, then transforming the data, it comes in under that only. Then dimension reduction. Dimension reduction is also another part, very important part of the pre-processing system, so that we don't have to pass too many features into the machine learning model, making it overly complex, and the machine learning model can overfit on the data if we uh, pass too many features there. So dimension reduction is another important part there, and this comes after all this pre-processing. It all comes under the suitable, we have a suitable data set after that, and then we will jump on to the phase 2 for the project, that is feature engineering. So feature engineering includes the data analysis part. So we will analyze the various features from the clean data set that we have received from the previous phase, and then we will analyze those features we will perform feature selections, feature extraction, feature engineering, and other so basically what feature selection includes here is uh, uh, feature selection. Basically we use various machine learning algorithms like lasso regression or random forest, so that we can get a particular set of feature importance, and after getting the feature importance we can perform the feature selection, so that for our stock market prediction model we get important features only, and not those features that are totally unrelated or not at all participating in the model performance. We can also use various statistical analysis algorithms like correlation, and using correlation analysis also we can directly find that which features are directly affecting our target variables or not. Then we have feature extraction. We can perform, we can create the new features from the raw features that are already present. And basically feature extraction, since it's a numerical data, we can perform feature extraction, but most in most part of it, it will come under feature selection, because uh, we will be performing the correlation analysis under here. And also if in the previous part we have already performed, would have already performed dimension reduction if the number of features are very huge. Then there will be feature engineering. Using raw features we can uh, create uh, new features, like new dummy variables for like working days. This is an accurate example. So uh, we can create more features, like we can also if we have stock market data, we can we have the data regarding the date and the prices of the stock market. So we can split the we have the feature of date, so we can split the feature of date on year, month and date, the particular date of the week. So we can also analyze using that feature engineering problem, on a particular day of the week, either the market is going high or the market is going low. And we also have the we will also be having the time variable there. So again we can split the features of the time variable, and again analyze the feature of the date and analyze
Kushagra, are you there?
Yes, ma'am. Actually, my college Wi-Fi just got disconnected
Okay,
because of electricity problem in college.
no problem. You can start again.
Yes, ma'am. Uh, should I start from the very beginning?
No, no, no. Where you left, you can start from there itself.
Actually, ma'am, I don't have idea where I left because I, just
You were on the
checked.
slide of feature engineering. You were
Okay,
explaining that.
okay, ma'am. So, can you see my slide?
Yes, yes. You were explaining the feature engineering portion.
Yes, ma'am. So feature engineering, again, feature engineering, feature selection, extraction, feature engineering, and feature learning. These four parts are quite important when it comes down to stock market data, because we have to split especially the date and time variable of the stock market data. We have to split the date variable also, date feature also into, like year, month, day, and weeks. Again, we have to split the time variable also into hours, minutes, or seconds, and we have to analyze the stock market prices based on those splitted variables. So there the feature selection, extraction, engineering, and feature learning, these four becomes quite important in that case. That's why feature engineering is one of the most important phase here, so that we can get the important variables to include in the important variables and important relationship to include in a stock market prediction model. Then
Sorry for interruption, Kushagra. If it's possible, try to put on your camera as well. It's important.
okay, okay, ma'am.
Yes.
Okay. Now, coming on to the phase three for the project, model development. So, model development here means developing a machine learning model based on the feature engineered data that we have got. So, after performing the feature engineering and selection, we get the required data, the important data that we have, and we will use that important data to predict the future, the predict the stock market prices. Now then comes what model to use for that prediction part. So there is no particular guidance against what model to use against a particular data. So what we have to do here is we have to perform experimentation using various models like decision trees, linear regression, random forest, XGBoost. We can use various models. We can also use bagging. Bagging algorithm basically means using two or more models, and having a collective answer out of that, a majority answer out of that. So that is the algorithm. Then similarly, there are various models we can use for that model development phase, and that phase will last for 4 weeks. It's an estimation. So training, it also depends on the amount of data that we have. If the data is quite huge, then the model training time will also increase, and so will the experimentation time. So it all depends on the data, and also the accuracy that we will be getting of the stock market price prediction. So we can again, after training the model, it does not end there. We also have to optimize the model hyperparameters. Like if we consider the decision tree only, so we have to optimize what should be the depth of this decision tree, or if we are considering random forest, how many decision trees should be there, and whether we should prune the decision tree or not. Or if we are using regression and we are using regularization. Regularization is basically a penalty, so that a model does not overfit over the data. So again, if we are using that penalty, how much penalty should we be using? So these all comes under the optimizing the hyperparameters for the model. Then we also have to evaluate our model based on the appropriate metrics, and based on we will get a chart of various models, their accuracies on our data, our feature engineer data, and then we will select an appropriate model out of that. Next comes the deployment phase. This will be a short phase here, 2 weeks only. we will be deploying the best performing model that we have chosen from the previous phase, and we will integrate that model with the stock market data feed. Uh, s- uh, it's it's only prediction. It's another feature that can be added to the project. Currently we have to deploy the best performing model on the cloud platform, and develop a user friendly interface so that we can the user can interact with the model uh, in a user friendly manner, and not like a particular coding manner. So this is the uh, part of the model deployment. We can also integrate the model with a stock market data feed for like real time prediction, but then it will also include training that real feed data with the model, best chosen model, and that will be real time trained model, and then it will again become more complex, but it's a suggestion for the improvement in the project. Then comes, after deploying the model, we can test that on various other data sets. Like we can provide the data set out of our distribution, and we can check the accuracy, and based on the accuracy we can evaluate our model, our deployed model. Is it working? Either is it working or not. Like here it's the process as shown in the figure. The data set is here. Then we split the data set into training, testing and validation. So this training data set is used to train the model. We optimize the model based on the accuracy of testing data set, and we evaluate our model based on the validation data set, that is after model deployment. So this is the whole process of model testing and evaluation. Then coming on to the deliverables for the project, we have to deploy a machine learning solution, and it should be a ready to use predictive model so that we can predict stock market prices using that model. And it should be a user friendly interface so that any user can easily interact with a model, and have predictions for them ready at the tip of their fingers. And then we also have to provide a report, like what methodology we use, what are the results, and what are the future recommendations, benefits or risks for the projects. Then the benefits that can be there for the projects, like it can empower the investors. Many investors, it's a trend nowadays, many people invest in stock market. So we can use the data driven decisions so that we have a more data driven decision, and we can have a more beneficial outcome for our investment when related to buying and selling the stocks. And we can also improve our accuracy in this project by making we can provide reliable prediction by having machine learning models rather than the time series traditional models that are being used till now for the stock market prediction. And we can also, again, we can employ the real time insight. It's a benefit we can include here. Like we can have a real time stock market application prediction here, but currently we will be using historical stock market data. But this can be an improvement here. And again, by working on this project, we can have valuable insights on we can also learn what stock market is, and we can also learn how to uh, uh, using feature importance, what are the variables that actually affect stock market behind the scenes based on the data. So this is again a great learning opportunity also in this project. Then the risk in this projects are data quality. One of the most important factor here is the stock market data quality that we get should be a high quality data and not a low quality data. The data should be correct also, because the investors will be investing their money based on our data and based on the our model predicting on that data. So if the data quality is poor, then our project, our investors will risk at a huge loss. So we have to prevent that. at any cost. Then we also have to prevent model overfitting. It's one of the most usual machine learning problem that we face. Model overfitting. Our model is trained on our training data, and it only recognizes the distribution of that training data only, and not at all work on the testing or validation data. So we have to prevent that, and we have to prevent that model from losing our generalization, and so that it can work on the testing data and the validation data. And market volatility. Now market can be very volatile in nature, so it's another risk of the project. Even if we provide machine learning solutions, the if a market tends to be volatile at a particular time, then it cannot be predicted at all by our machine learning model. So again, it's one of the risk factors here. If the market turns volatile, then all of our predictions will fail. So again, it will just come to a dead end. So these are the risks that will be there in the project. Then coming on to the conclusion, the project basically aims to revolutionize the stock market investing. We will be investing on stock market based on the data driven decision, rather than on historical methods, or based on brokers or any other things. And then this is the end to end project. We will be collecting data. We don't have any data present. We will be collecting the data. We will also be analyzing. We will be cleaning the data. We will be using feature engineering. Then uh, from model, we will also be using model development, model deployment, and evaluation. So this will be a almost 12-week project, and it will be an end to end project from data collection to model evaluation. So any questions? These are the references for the presentation, and thank you.
Yes, Kushagra. Do you know what are the different ways to when we pre-process the data?
Yes, ma'am. We can pre-process data using various ways, like data cleaning. We can also perform outlier analysis. We can do correlation analysis, so that we can reduce the variables. We can check on eigenvalues analysis using PCA, so that we can find out data which shows the maximum variance, and we can only select those variables. So these are some of the ways.
Okay. So do you have any idea about simple imputer or label encoder? You told in your one of somewhere that
Yes.
we use label encoder or one-hot encoder. Do you know what purpose we are using that?
Yes, ma'am. Basically, when we use one hot encoding, so like if a categorical variable does not have any inherent, numbering order or inherent order, like if a categorical variable is a grade, and the grades are A, B, C, D, so that grades has an inherent numbering order. So we can perform label encoding. It will assign a number 1, 2, 3, 4, 5 to those grades, different grades. But
Means in simple language, I can say that you are trying to say that we are converting a string object into numeric value. This is
yes,
the
ma'am.
main work of.
Yes, ma'am.
Okay.
But there are two ways here, so
Okay.
it depends.
Okay. And do you know the difference between feature selection and feature extraction?
Uh, yes, ma'am. Feature selection and feature extraction, basically. Feature selection, what happens in feature selection is, ma'am, basically in feature selection we get an array of importance values using various algorithms. Like if we use random forest or lasso, these are the two algorithms that I know. They give us an output of feature importance here for each of the feature variables. So when we get the feature importance for each of the variables, we can select few of the features that shows most of the importance, while we can discard the rest features, so that we can reduce our data. And feature extraction is basically similar to like dimension reduction or other techniques. It's not similar to feature importance. So feature importance shows the importance towards the model, but in feature extraction we might exclude some of the variables that are important to the model also. So feature selection is different in that way.
But both are same thing. Either you say it's dimensional reduction or you say you are picking up important value. Any other difference,
Yes,
other
ma'am.
than
In feature selection, we are when we are picking on the feature importance. What we do is we use a particular machine learning model, and based on the outcome of that model, we select the features. And in feature extraction, we check the variation of the data. So the variation of the data might not, the outcome might not give us the valuable result here. It might or might not give, but in feature selection we for sure know that these features are important, and if we exclude those features, those remaining features, then our model will not be affected at all. So that's a difference here.
yeah, you can do more research, but one difference that I know is that in feature selection, both are same thing. These come under the feature engineering techniques, feature selection and feature extraction. What happens in feature selection? Basically, you are picking up the most relevant attributes of your data set, but the original value does not change. The numeric value that present in the data set, while in feature extraction, our original value of the data set gets changed. You can do more research. Okay.
Yes, ma'am.
Rest, your presentation was quite good. And yes, you can try to add a short story in the beginning of your presentation, just to show that what is the relevance of your project and how it is implied in real world, means how it is solving the real world problem.
Okay, ma'am.
Okay, rest everything was okay. This is
Okay.
all from my side.
Okay. Thank you, ma'am.
Next, we have Rakhi. You can start your presentation. Rakhi, please turn on your camera as well. Rakhi, you are not audible to me.
My screen is visible, ma'am.
Yes, your screen is visible. You can start.
Hello, everyone. My project name is Cloud Engineering Internship Program, and my task name is set up an Amazon RDS instance.
Sorry to interrupt, Rakhi, but you are not visible. It's quite black. Please check once again. It's important to. Okay, now it's fine.
So, hello everyone, my name is Rakhi and my project name is Cloud Engineering Internship Program, and task allotted to me set up an Amazon RDS instance and am from to cloud computing group. So move on next slide. So this is the content of my task. First is database Amazon RDS. Why use Amazon RDS? Amazon RDS database engines and how to create an Amazon RDS, features of Amazon RDS use cases, then conclusion. So what is Amazon RDS? Amazon RDS is a relational database service. It is a fully managed service. There are many different types of database. We can broadly speaking, database engines are two types of relation. There are two types of relational database, relational and non-relational. So the example of a relational database is a MariaDB, PostgreSQL and many more. And non-relational database example is a Mongo, which is followed by Redis. Redis is, you can say, it is used for cache and a long-term data storage. And let's move on next slide. So what is database? A database is an electronic stored systematic collection of data. It can contain any systematic collection of data. It can contain any types of data, including words, number, images, videos, and files. In computer system, the word database can also refer to any DBMS, to the database system, or to an application associated with the database. So why database is important? So database important because it supports the internal operations of companies and store interaction with customers, and it provides administration information and more specialized data such as engineering economic models. And it gives an example of database. It includes digital library systems and reservation systems. And you can say why database are essential, because database is essential for efficient data security, data analytics, data integrity, and efficient scaling. Then let's move on next slide. So what is Amazon RDS? Amazon Relational Database is a managed SQL service provided by Amazon Web Service. It supports an array of database engine to store and organize data, and it helps to relational database manage tasks like data migration, backup, recovery, and patching. Cloud administration is used Amazon RDS to set up, operate, manage, and scale instance of cloud databases. Amazon RDS itself is not a database. It is a service used to manage relational database service. Let's move on next slide. So why use Amazon RDS? Amazon RDS, the primary reason to use a database is to store relational database are the perfect tool for storing, organizing data. For most application, only works with specific data sets. For example, you are building a point sale on application for grocery store. You need to know what types of tools in that grocery store has, and each number of items, and the number of items and cost of each item, and the cost, and you have to give such an item at given time. Then relational databases are the perfect storage mechanism for this type of related data. As an application developer, you understand what kind of data is being stored in that database. So you can leverage the fact that in your database for a specific SKU to find a product price. Let's move on next slide. So what is Amazon RDS database engines? So first is Amazon Aurora, second is MariaDB, third is MySQL, fourth is Oracle, fifth is PostgreSQL, then Microsoft SQL. So first we discuss about Amazon Aurora. Amazon Aurora is a fully managed relational database service with MySQL and PostgreSQL. It includes a high performance storage subsystems. Amazon Aurora provides a 5-time throughputs to MariaDB and 3 times throughput to PostgreDB. Amazon Aurora is a managed service by database service relational database. Relational database is a service that makes it too easier to set up and scale a relational database in the cloud. Then we discuss about MariaDB. MariaDB, it is a popular open source relational database service which is original for developers for MySQL. Amazon RDS makes it easier to develop, set up, and scale MariaDB servers deployments, and it's scalable for MariaDB cloud databases in minutes with cost-efficient and resizable hardware capacity. There are many versions of MariaDB, such 10.3, 4, 5, 6, that are the code applications that tools you are already used in today that can be used to Amazon RDS. Then MySQL database. MySQL database is a database management. It is a client servers that supports of multi-threaded SQL servers that supports for different backends, servers, different clients, per programs, and you can say libraries, administration tools, and wide range of application programs. Then we discuss about Oracle. Amazon RDS. Amazon RDS is a fully managed commercial database service. Make it easy to set up, operate, and scale Oracle deployments in the cloud. Amazon RDS frees up to focus on innovation of applications, consuming database, provisioning, patching, backups, and software patching and hardware scaling. Then PostgreSQL. PostgreSQL, it has the open source relational database service for many enterprise developers, startups, companies, and mobile application with Amazon RDS. You are deployed to scalable PostgreSQL deployments in a minutes with a cost-efficient way and resizable hardware. It is easier to deploy. And last is MySQL database engines. MySQL database engine is a relational database engines managed by Microsoft. Amazon RDS for SQL server make it easy to set up, operate, and SQL servers and deployments in the cloud. With Amazon RDS, you can deploy multiple editions of server depending upon Express Enterprise backups with cost-efficient and resizable compute capacity. Then let's move on next slide. How to create an Amazon RDS. So there are many steps to create an Amazon RDS. So first is log into AWS Management Console. Then second step is click on services, then search on database and go to the RDS. So after click on RDS, you will see the dashboard of the database. Then create a database, then click on create a database. We will see two types of creation method. First is standard create, second is easy create. Standard create means it is a setup for configurations like availability, security, backup, and maintenance. And easy create method is RDS follow easy create method for best practice provided by AWS. Then engine options. Then choose MySQL database engines. Then engine version. Then we choose engine version is by default. Then we will choose templates we will choose free tier templates. For free tier templates, availability and durability is disabled. Then fifth step is in the settings selection, go down to DB instance identifier, then give a master username and master password, then confirm master password. So we can see we give a DB instance identifier name, then master name, then master password, confirm master password. Go down and we see instance configuration, storage, and connectivity. So these are the by default settings of database. So these are no changes. Then create a database. Then create a database and click create database. Now wait till the database is created and status is available. database status is available. Then click on DB instance details button. Now it is available for 4 to 5 minutes after. Then now it is available. Now you are going to connect your your database to MySQL cell. Before connecting to the cell, you click on your database and copy the endpoint of your database and it pastes to the. So we can see endpoint and port. So these are the 2 points to copy and paste on MySQL shell. Then open your MySQL and paste this command with your username, endpoints, and port number. Once you click enter, your password will be needed. Then after we will entering the password, we will are login in MySQL database. So this is the process of how to create an database engine. So next slide is features of Amazon RDS. So there are many features of Amazon RDS: security, cost effective, scalability, free tier, high availability, and durability. Security: use AWS key management service. You can create an encryption key for maintaining security. Cost effective: you just pay for what you use and nothing more. There are no upfront payment is needed, just for monthly uses payment. Then scalability: it just take a few minutes to scale your infrastructure or down, and you can scale up to maximum of 32 for CPUs and 244 gigabytes. Free tier: AWS gives you a free tier usage of Amazon RDS for 750 hours and for 12 months. High availability and durability: multi-ages provide high availability and durability across the globe, and you automated recovery features of RDS enables point to time recovery for your database engines. Let's move on next slide. So these are the Amazon RDS use cases. So online retailing, mobile and online gaming, travel application, and streaming applications. So online retailing, these applications manage complex database that tracks inventories, transaction, and price. Mobile and gaming applications: RDS provides many applications like ARB, takes an advantage of RDS ability to simplify time-consuming database administration tasks, and it automate database applications. Travel applications: in travel applications, mobile app like Airbnb also take an advantage of RDS scalable storage capability. Then streaming applications like Netflix takes an advantage of RDS storage scalability as well, and availability of Amazon RDS, which allows them to handle high speed, high demand daily. And let's move on next slide. So this is the conclusion of this task. So Amazon Relational Database Service is a fully managed service provided by AWS that makes it easy to deploy, scale, and maintain relational database in the cloud. RDS supports multiple database engines such as MySQL, MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server, and it handles routine database administration tasks such as backup, software patching, and hardware scaling. And you take consistent and on-demand snapshots long as the user wants. Then RDS allows user to focus on their application and business logics rather than the underlying infrastructure. So these are the reference links. If you have any question, please ask me, and for any query, please contact me. Thank you.
Yes, Rakhi. So
Yes,
one
ma'am.
thing I would like to say, try to add a short story in the beginning of your project, okay? Because it basically creates a scenario in the audience mind that why you are doing it. Means you are relating your project with the real world scenario and how you are creating a creative solution for it. Okay, and in the initial
Okay.
slides, I saw that you just wrote your content in paragraph wise, but try to short them and keep them in a points. Okay,
Okay,
and
ma'am.
again, I would like to repeat that please don't read out the points that you have written on the slides. Just read it and explain it what you understand, because we are
Okay,
actually
ma'am.
what is written we just know, yeah, it's that, but what you actually extra you learn from it, it's more important. Rest,
Okay.
your flow was good and presentation was quite well. This is all
Thank
from my side.
thank you, ma'am.
Welcome. So we are not left with any more presentation now. So we are wrapping our session. Thank you, everyone.